Hi, I'm Michael Forrest, and this is part 2 of my devlog, which is about RealtimeSwift, which is going to be a SwiftUI-style declarative real-time rendering engine. Basically, I want to wrap up typography, video, and audio compositions into a declarative syntax that I can use to simplify my video production software that I'm currently recording in. So I woke up full of ideas this morning, thinking about all the things I could set up. So what if I could have movie source name? So we have some sort of things keyed on names, that's fine. I can already play videos, but okay, let's have a modifier for the volume. That seems good. Headphones, that's kind of fun, right? So now I've got two different audio outputs. I've got one for headphones. I've got one for the, one for the virtual mic. So that would be nice to have in a modifier, and it can I can set the volume on that maybe as well. Maybe playback rate, that's a modifier, that could be cool. And then what if we started doing some crazy stuff like, okay, when you start and stop the video, it does a tape stop effect, like the Teenage Engineering OP1, which would just be like an A vary speed module, but it's one of those things that I'd like if it would be much easier to kind of separate that from everything else and kind of work on it, whereas at the moment everything's kind of mixed in together. So I'm using just to say, for the audio, I'm using TheAmazingAudioEngine 2, which is basically C callbacks, and the sample code is in Objective-C, so that's kind of what I followed. But now that I'm more comfortable with C interoperability in Swift, I'm kind of thinking about how this could all look in Swift. I could save myself some header files and bridging headers and all that stuff, and use convention C and that kind of thing. So, and then I could, we've got some nonsense here, literally, where is it? The current magic wand volume is literally in my main audio controller because I just needed to get it to work. It's all real time. And it's the same with the virtual mic. It's currently about 4,000 lines of C. And it's all these, it's all pretty boilerplate, but I'm just copying the input to the output. But it's a lot of C, and I just think this could probably be done in Swift, and I could save quite a lot of code, and it would all be a bit more robust and a bit easier to maintain. And I might finally, instead of having a slightly janky, at the moment I'm just I've set it up as a virtual audio thing, but any app can send audio to it. Really, I should be generating audio buffers and sending them through XPC calls into the other thread or whatever, into the other process, and then it kind of populates it that way so that only QCam can do it. But there's benefits to other apps being able to send stuff to the virtual mic, but it's just this was a lot to learn, so I didn't really try that. So the other thing, I've been thinking about double buffering and how I can minimize how many textures and surfaces I'm creating to get my average memory use stat. So QCam is currently sits around 1.8 gigabytes of RAM. And then I was also thinking about crazy graphical effects. What if I could do videos like this in real time? So, but it's really not all, it's really all about not having those little glitches when the videos start playing. So I bet if I were to pause my, I missed it. I bet if I were to, pause that video, let's just, I'll just kind of go back into it, and you see the little kind of glitches. So I think I should be able to see that. You see it goes black for a frame. Yeah, it's just very, it's not as good as it could be. By the way, I just rewound time on the iPad, so that's quite clever, isn't it? But yeah, I did start the day optimistic, and then I spent the first 5 hours of my day being confused about how to make this work. So this is just a conditional view, and it was just giving me errors. Ignore, this is just to make it, I just dividing by 2, so just every 2 seconds I want it to appear and disappear, right? And this just was my whole day basically. So what this needs to work, so I've got my basic result builder stuff here, so my 4 basic things, but it turns out you need this other one, this build optional support for if statements that do not have an else. So I had to figure out how to build that, but I don't really understand these extra result builder functions, and I ended up watching this 45-minute video on WDC video from like 2021, I think. What's it called? Writing a DSL in Swift using result builders. This is actually one of the best WWDC videos I've seen, like working through all the strange error messages and like not trying to cover it up, like variadic arguments of types. You know, it's like, oh my God, what is this? But yeah, I still had to figure out how to build a so even though when I sort of understood that, I still had to solve this problem of like I've got my protocol, which is real-time view, and I can't return any real-time view because it just kind of gives you this problem. It can't, you know, can't infer the content type, and this all needs to be like all sort of strictly, it all needs to be concrete types for this whole tuple view thing to work. So it means I can't really return any real-time view, and also I can't do that if this is optional either, because you don't know what type it is. But there's just I just realized I needed to make that work. I needed to do some kind of type erasure, but I was trying to get ChatGPT to help me, but it just was not giving me any working code. So if I kind of show you like what I was you know, like this is like one of about 6 conversations this morning. So I'm like, how do I actually erase this type? Like I've got, you know, some real-time view, and it goes any real-time view. Okay, cool, any real-time view. That sounds good. And then, okay, so, and then I think like this isn't wrong. Like the fundamental idea is like take the kind of results of basically extract all the bits out of the protocol, all the expectations, and just store those as properties instead of storing the original type. And then the real-time view can conform, can have a body function which just uses the stored value. But you know, I just couldn't get it to work. I couldn't get any of the code that it gave me to work, and then it just kept sort of. It will say kind of the same thing, but it will nest it one level deeper, and it will just gradually get more and more confusing. But I think what actually the problem with this was, I don't want all my bodies to necessarily, some of the bodies shouldn't be called because they're leaf nodes, so they will like, there'll be a body type never, which then means that you can't actually just call view.body because it might not be appropriate. So basically I spent a long time kind of going back and forth with ChatGPT, and it kept kind of coming back to this kind of like, just put an else branch, or put empty view builder, or like use this build. It kept saying I could do this, and you just can't do this. Like that just wasn't going to work for me. And then I did find this really good forum post where someone's basically trying to do what I'm trying to do. So this is on the Swift website, but yeah, just someone's sort of explaining how SwiftUI kind of works behind the scenes, and they've got this kind of like type erasure, public-private protocol thing. So like they've got the public one, but there's a private thing that implements everything like transparently for normal stuff, but then for this stuff it does it. But I couldn't even get, and then something about SE, you know, SE 0309 implications, and then so. And I knew that's actually out. I kind of went into it, and it says that it's you know, implemented in Swift 5.7. So I thought, okay, well, does that mean this should be easier? But even like I couldn't really figure it out, and I pasted it into ChatGPT as well to sort of give it context, and it still couldn't work it out. But actually, I ended up doing it my own way in the end. Anyway, so here's what I eventually did. So basically, I got my my build optional. Takes this optional real-time, just returns, so some real-time view, it just returns this concrete optional real-time view content type. And then that optional real-time view basically does the same thing as these tuple views. So it just takes a type and then just like stores it, and like, you know, doesn't do anything else. And so the sort of breakthrough here was like, actually, it doesn't really matter at that point. It only really matters once I resolve the node. So I do this like little optional real-time view resolvable dance at resolution time. So the views just contain the raw types, and I only pick them apart when I resolve the render nodes. So basically, I'm sort of expecting either 0 or 1 node as a child. And actually, like I've even refined this since. But the basic idea is like resolve it, and then I'm annoyed that I want to show you the real one. I'll show you in a minute. I actually tidied this up. This is, but basically you see I'm doing this mirror reflecting value children dot first, and then if I have a child, which is a real-time view and I can resolve the node, then I use that, and otherwise I just like give it nothing. But this is that it's a bit tidier in my latest version. But then this lets me call erased resolve. So I go, if it's a wait, no, not that one. So if it's an optional real-time view resolvable, then I get this erased resolve view, and I can just like jump into there. And then erased resolve, this is, wait, what did I show you before? Yeah, so this is actually the real one. So this is what it really looks like. So we have optional child mirror reflecting value children dot first, and then I just sort of like, the node is that or that, and then I just do this resolved optional real-time view node, which then means that I can just return the, in here, I can either return the node or return nil, right? And so this, yeah, the thing with that is I also made this render node optional. So basically when we're parsing through the tree, now when it actually comes to getting those render nodes, I can sort of like pull apart that struct and just like see if it's got any children. If it has, then I've got the node. If it hasn't, then it hasn't. So I don't know if there's a better way to do this. I tried, I think this feels quite neat. It's kind of using the same pattern as I did elsewhere, but now this means that the nodes can disappear from the render tree. So that was all very painful. It was probably a bit painful, you know, I think like doing these videos is a way for me to just straighten my thoughts out, right, and just really sort of understand it. And even just the fact that I, in the process of writing up this video, I kind of tidied up that optional render node thing, just goes to show that, like, even if, I don't know if you're getting any value out of this video, but I know that, like, just putting it up there is just a way of me kind of just shoring up my work a little bit. So anyway, like now it just means, the next thing here is I can watch for changes and recalculate the changes. So basically, we've got this with observation tracking on our tree, and each time it changes as a result of this, we basically compute the diff from the current tree, which can be optional. So we get, you know, we get everything added by default, and then that just works like this. So basically, I've got this. I've got this identity, real-time identity, identifiable, I think it's called, which then conforms to hashable. So all my comparisons, I'm just kind of having to go in and get the hash value to do those actual comparisons. That was another bit of confusion for me today. But yeah, like, and then we're just sort of returning either like node added, node removed. My son is banging on the door. And then node updated. So now basically you can see that this is what that looks like. So I've got my little test document here. I've got a few different layers, and you can see number 5 is kind of like appearing and disappearing, and you can see that down here we've got those node changed. I think they're doubling up. I'm not gonna, we'll get into what's going on with the doubling up of messages when I get to it, but you can see I'm now getting, here are the changes that are happening. Here's the view tree mutating as time goes on. And I'll just show you that a little bit bigger so you can sort of see, you can just sort of see that that's kind of like flicking in and out, especially if my face isn't in the way. So yeah, I've just got like my data is divisible by 2. So yeah, anyway. So that was no fun, but hopefully next time I'll have something a bit more exciting to show you. And I'm just going to say, like, this, I kind of made this whole video in QCam Presenter, so I'm just going to show you what that looks like. Where is it? Converting a Swift number 2. Yeah, so this is the one I've just been through. This is my document. So I just did a lot of screenshots today in the odd, so there's like a browser share there. I sort of shared screens on there. I can sort of turn these on and off. I can play back a video, which I did on this card, and then I had that cropped in a little bit, and I had it to go to the next card when it finished, just for that timing. And then I also used, I've got Video Pencil here, so when I draw I'm sort of drawing on here and I'm seeing whatever's on the desktop down here. And also like I can like rewind, so I can actually like hit pause here and like bring everything backwards and forward. I don't think it's going to work in demo mode, but that might have been fun to show you. But yeah, so this is kind of my setup. I've got the teleprompter, but this is all being driven by my own app, QCam Presenter. So I hope you, do you know what? I think you might not be seeing my desk view. Let me just exit demo mode. Yeah, so this is my desk view. So here's the desk. Here's the here's my iPad, which lets me draw. Here's my teleprompter, which is where my script is going to, and then the cards are kind of on there, and this is the screen that's getting shared. So yeah, I just wanted to show you like this is kind of like behind the curtain, and this is kind of the software I'm using to build this. And you can try QCam at qcam.app and just download that. Now, thank you for watching. I'm definitely thinking about how to open source this at some point. I think it would be cool if this was out in the wild. So if that sounds like something you'd want to collaborate on, let me know, and hopefully see you on the next one. Take care. Bye bye.